Hi. So in this video, what we're going to talk about is vectors, but in 3 dimensions. And really, we're not actually going to be doing anything new other than considering them in 3 dimensions. We're just going to be doing everything we've previously learned with vectors, but with a third dimension. Okay, so if you think about 3 dimensions as being x, y, as you would normally see the coordinate axes, and then this third dimension z. Okay, so if you think about a 3-dimensional room, you're going to have the x-axis, you're going to have the y-axis, and then you're going to have the z-axis, all 90 degrees from each other. Okay, and it's really quite straightforward, I think. It's just, instead of just having x and y components, you get x, y, and z components. So really it's just an extra number, as long as you do it correctly. So for example, 2a, we're just going to go 2 times whatever a is, which is 2, 3, 4, plus 3 whatever b is, which is 1, negative 3, negative 9. And then so it's going to be 4, 6, 8, plus 3, negative 9, negative 27. And then you add them and we get 7, negative 3, negative 19. So really there's nothing fundamentally different about the mathematics, it's just that there's a third dimension and a third component. So again, 5a minus b. So we get 10, 15, 20, minus 1, negative 3, negative 9. 10 minus 1 is 9. 15 minus negative 3 is 18. 20 minus negative 9 is 29. Okay. So if you could do it in 2 dimensions, you should, in theory, be able to do it in 3 dimensions. Okay. The same applies for almost everything else we can be doing. For example, position vectors. Calculate the vectors between the following pairs of points. So I want the vector AB. Nothing's changed. It's just still b minus a, except now it's 3-dimensional. You're still subtracting this. You're still doing the second coordinate point minus the first coordinate point. Negative 3 minus 1 is negative 4. Negative 8 minus 7 is negative 15. 2 minus 9 is negative 7. Yeah. So again, mn will just be n minus m. Negative 2, 7, negative 1, minus 0, 0, 5. Negative 2 minus 0. 7 minus 0. Negative 1 minus 5. And that's doing the position vectors in 3 dimensions. Okay, so then the next thing we learnt was calculating the magnitude. So we'll calculate the magnitude of the position vectors just found. So I'm just going to rewrite them. AB was negative 4, negative 15, negative 7. And mn was negative 2, 7, negative 6. Okay. So it's just the same formula, but with a third component. So magnitude AB, remember your lines, will equal the square root of negative 4 squared plus negative 15 squared. Now the only difference is we've got z component, so it's add negative 7 squared. So 16 plus 225 plus 49 square rooted. Gives us 17.029. The same again for mn. Magnitude mn will be square root of negative 2 squared plus 7 squared plus negative 6 squared. So it's going to be 4 plus 49 plus 36 square rooted 9.433 9.43 to 2 decimal places. Okay. Then we come to alternative vector journeys. And again, it's a bit maybe harder to conceptualize and visualize on a 2D piece of paper for a 3-dimensional journey, but in theory it is actually the same. As long as the start point is correct and the end point is correct, and you've correctly summed the vectors, then these will all be correct. Okay, so we're doing the vector P to D. And hopefully what we can see is the vector P to D is parallel with BC. So they're going to be the same vector. So it's just Q. And it's pointing in the right direction. C to D. So it's going to be parallel with BP. We look at the arrow, it is going in the wrong direction. So we need to just make it negative. B to E. And again, this is where it starts to get a bit more complicated. But we can just go B to C and then C to E. And we can see that that's just going to be Q plus R. That should be E. And that should be E. Nope, that should be P. Okay. So we're doing P to E. So we're going there. So let's go along P to B. And then B to C. And then C to E. So it's just going to be P plus Q plus R, which you could have got as well by doing A to B and then B to E, because we know B to E is Q plus R. E to D. So we can just go E to C, because we know that one, and then C to D. E to C is negative R, and then C to D is negative P. Last one, we're doing P to C. Again, it's just colored pens. P to B and B to C, so it's just P plus Q. So again, if you could manage it with 2 dimensions and you can visualize it with the 3 dimensions, you should be fine. Okay, just one last bit. One extra thing that we might have to do with vectors sometimes is interpret 3D diagrams and correctly put in the coordinates so that we can then calculate the vectors. Okay, so you'll be given information and it'll be a regular 3D object, and then, so for example, in this point it says, shown is a diagram of a cuboid that measures 10 units by 4 units by 8 units. So that can be written in. Using this information, write down the coordinates of the 7 vertices remaining, because I've already given you the origin, which is at 0, 0, 0. And so we just need to think it's always just like X and Y axes, it's X and then Y and then Z. So we just have to try and visualize it. So let's do A first of all. I'm going along the X axis and I'm going along 10 units. And then I'm not going on to the, I'm at the point, so I'm not going on to the Y axis, I'm not going on to the Z axis. So it's just 10, 0, 0. So B, still follow the directions, 10, and then 4, even though it doesn't look like that as a 90-degree angle, it is, because it's just hard to represent that on 2D paper. So 10, 4. And am I going on to the Z axis? No. So it's 10, 4, 0. So here, see, I actually don't have to leave the X axis, so the X coordinate is going to be 0. And then it's 4 units because it's the same size. And again, I'm not going on to the Z axis, so it's 0. D. I'm not moving on the X axis, I'm not moving on the Y axis, and then I'm going up the cuboid 8 units. So it's 0, 0, 8. Am I going on the X-axis? No. I go along the Y-axis, 4 units, and then I go up 8 units. So it's 0, 4, 8. Almost there. 10 units along. 4 units along, 8 units up. And then lastly, 10, 0, 8. And that's interpreting 3D diagrams.